Last summer, my friend visited Russia without speaking a word of Russian. Yet she had no trouble reading street signs, menus, or directions. How? Her phone instantly translated everything using something called a neural network. But what exactly is a neural network? What is the human brain analogy? To understand neural networks, we need to start with the most amazing computer on Earth, your brain. Right now, as you're watching this video, billions of tiny cells called neurons are working together in your head. Think of a neuron like a tiny messenger. It has three main parts. Dendrites. These are like little antennas that receive messages. Cell body. This is the brain of the neuron that processes information. Axon. This is like a wire that sends messages to other neurons. When you see a red apple, millions of neurons pass messages to each other. Some neurons say, "I see red." Others say, "I see round shape." Your brain combines all these messages and says, "That's an apple." Scientists thought, what if we could copy how the brain works and put it inside a computer? And that's exactly what they did. What is an artificial neural network? An artificial neural network is like a simplified version of your brain, but made with computer code instead of brain cells. Just like your brain has neurons, a neural network has artificial neurons. We call them nodes. These artificial neurons are organized in layers. Imagine them like floors in a building. Input, layer. This is the ground floor where information enters. Hidden layers. These are the middle floors where the real work happens. Output layer. This is the top floor where we get our final answer. But here's the magic part. Just like the neurons in your brain are connected to each other, these artificial neurons are connected too. These connections have something special called weights. Think of weights like volume controls. Some connections are turned up loud. They're very important. Others are turned down quiet. They matter less. The network learns by adjusting these volume controls. Now, how does it learn? Remember when you were little and learned to tell the difference between a circle, square, and triangle? You saw many examples until your brain figured out the pattern. Neural networks learn the same way. Let's say we want to teach a neural network to recognize circles. We show it thousands of pictures. Some are circles, some are not. At first, it guesses randomly and gets most answers wrong. But here's where the magic happens. Every time it makes a mistake, the network says, "Oops, let me adjust my connections." It makes the important connections stronger and the unimportant ones weaker. This process is called learning or training. After seeing thousands of examples, the network gets really good at recognizing circles. It went from guessing randomly to being right 95% of the time. The real-world examples. Neural networks are everywhere in your daily life. When your phone's camera recognizes your face to unlock, that's a neural network. When Netflix suggests movies you might like, neural network again. When your GPS finds the fastest route avoiding traffic, you guessed it, neural networks. When you ask Siri or Alexa a question and they understand you, neural networks are translating your speech. The coolest part? Many of these applications use multiple neural networks working together, like a team of specialists each doing what they do best. Why are they so powerful? Traditional computer programs work like following a recipe step by step. The programmer has to write exact instructions for every possible situation. But neural networks work more like how humans learn, by seeing lots of examples and figuring out patterns on their own. This makes them incredibly powerful for tasks that are hard to write step-by-step rules for. That's why they're revolutionizing fields like medicine, where they can spot diseases in X-rays, or art, where they can create paintings, or communication, where they break down language barriers instantly. So there you have it. Neural networks are computer systems inspired by the human brain. They learn from examples, adjust their connections, and can solve problems that would be nearly impossible to program traditionally. We're still in the early days of this technology. Who knows what amazing applications we'll see next? If you found this helpful, hit that like button and subscribe. Let me know in the comments. What would you like to see a neural network learn to do?